Good afternoon. Let me begin with a scene. It's 2 a.m. in the emergency room. A cancer patient arrives with high fever and lethargy, clearly unstable. The ER physician needs to make a life or death decision immediately. But all the crucial medical history is buried across hundreds of pages. Discharge summaries, radiology reports, scattered notes. In that moment, even finding one key sentence, like recent chemotherapy, can determine whether the patient survives. This is the reality of emergency oncology. And to solve this critical gap, we are here today. We are the team from Korea University, and we are proud to introduce OncoTriage AI. To demonstrate how we turn this chaos into clarity, here is our agenda. This isn't just an inconvenience, it's dangerous. Research shows that poor access to prior information in the ER leads to diagnostic errors, delayed antibiotics, and adverse drug events. Emergency oncology is especially high risk. If the doctor misses something, even small, like febrile neutropenia or TLS, the patient can deteriorate within hours. So the core challenge is cognitive overload in emergency oncology. Doctors are drowning in data. Patients need fast, guideline-aligned care. We need a system that turns data chaos into actionable insights within seconds. To address this problem, we built OncoTriage Assist, a web-based multimodal decision support tool designed specifically for emergency oncology. Here's how it works. The system takes historical unstructured text, current symptoms, and optionally voice recordings and processes them through LLM-based pipeline. It then outputs a structured clinical summary in seconds, automated charting to reduce workload, a mandatory oncologic emergency checklist for guideline safety. In other words, it delivers the right information to doctors at the right time.
Now let's see it in action. If we run the code, the web server will be activated. This process will be done before a patient arrives. This is the address of the web server. Now we connect it. A patient, P001, has just arrived. And first, I unlock the post-discharge summaries and radiology reports. This text file consists of very large and complex text, so doctors have no time to read it. And also, I upload the patient voice record file consisting of past consultations. And finally, I quickly type my observation that patient heart stroke. And behind the scenes, our backend is transcribing the audio, merging it with the history, and running it through our clinical prompt engineering pipeline. And here is the result. Look at this summary. It's organized into SOAP formats: subjective, objective, assessment, and plan. I immediately see the patient's primary cancer stage and history. Here's the most clinical part, the checklist. The AI correctly flags hypotension as yes, and elevated lactate as yes, immediately signaling hemodynamic instability. At the same time, recent chemotherapy and infection-related items are marked no, helping me rule out oncologic sepsis rapidly. And with the overall triage note, I get a final safety-focused clinical summary. This is more than a checklist, it's a real-time safety net.
Our system is designed for real clinical deployment. It's built on the Responses API, producing fast and schema-enforced output for safe integration. It supports speech-to-text and a feature-critic agent for verification. On the deployment side, it requires only a lightweight front end and small Python backend, so it can run on ED desktops or tablets with minimal setup. Because processing is stateless, it connects easily to hospital systems through simple REST APIs. What makes our system unique is its focus on emergency oncology. We've combined text notes, typed symptoms, and voice recordings into one structured summary. The output is guideline-driven, generating SOAP plus oncologic emergency checklist. We also use LLM recency bias intentionally, placing recent symptoms last so the model prioritizes what matters most in the ER. In practice, this helps reduce delays in recognizing oncologic emergencies and lowers charting burdens. We also address limitations. To reduce hallucinations, we introduce a critique agent. To manage recency bias, we control input on ordering. And to overcome domain gaps, we will fine-tune a medical domain LLM. Our next step is clinical evaluation. We plan to partner with hospitals to collect paired datasets, allow patient states, and physician-verified summaries. These will allow us to fine-tune our domain-specialized model for higher accuracy. We will also expand guidelines, TLS, SVC syndrome, spinal cord compression, and add real-time risk alerts. Finally, we aim for seamless deployment inside ED workflows and eventual EHR integration. By reducing chart reviews from 20 minutes to 30 seconds, we enable faster, safer decision-making for cancer patients in the ER. Thank you for listening.